This video is going to go through a center of gravity and parallel forces calculation. A bricklayer stands 2.50 feet from one end of a 7-foot scaffold that is uniform and weighs 25 pounds. A pile of bricks weighing 40 pounds is 3 feet from the other end. If the bricklayer weighs 185 pounds, how much weight must each end support? Step 1 in the parallel forces and center of gravity calculations is to draw a picture of the situation. We want to find the forces F1 and F2 on either end of the scaffold. We know the bricklayer weighs 185 pounds, so we will call this F3. The bricklayer is located 2.5 feet from one end. The bricks weigh 40 pounds and they are located 3 feet from the other end, which means they are 4 feet from F1. We are also told the scaffold is uniform, which means the 25-pound weight of the scaffold is centered at the middle of the scaffold, which is 3.5 feet from either end. Now that we have our picture drawn, step 2 is where we set the sum of the forces equal to 0. The sum of the forces have to equal 0, otherwise there would be some kind of an acceleration and we would not be in equilibrium. When we set the forces equal to 0, this means that the forces acting in the counterclockwise direction must equal the forces acting in the clockwise direction. Therefore, F1 plus F2 is equal to F3 plus F4 plus F5. We can substitute in values for F3, F4, and F5, so we have F1 plus F2 is equal to 185 pounds plus 25 pounds plus 40 pounds. Adding these three force values, we see that F1 plus F2 is equal to 250 pounds. Step 3 is where we choose a point of rotation. We will set A to be our point of rotation. It is helpful to set your point of rotation to be at the same location as one of your missing forces. Since point A is our center of rotation, this means any force arrows pointing down create clockwise rotation, and any force arrows pointing up create counterclockwise rotation. Next, in step 4, we need to find the sum of the clockwise torques. Remember, torque is equal to the force multiplied by the length of the torque arm. The forces that produce a clockwise torque are F3, F4, and F5. The sum of the clockwise torque is equal to 185 pounds multiplied by 2.5 feet, plus 40 pounds multiplied by 4 feet, since the bricks are located 4 feet from the point of rotation, plus 25 pounds multiplied by 3.5 feet, since the scaffold is uniform, so the weight force is acting in the center. After multiplying, we have 463 pound-feet plus 87.5 pound-feet plus 160 pound-feet. This means the sum of the clockwise torque is 711 pound-feet. In step 5, we need to find the sum of the counterclockwise torque. The sum of the counterclockwise torque is equal to F1 multiplied by 0, since the length of the torque arm for F1 is 0 due to point A being at the same location as F1. We will add this to F2 multiplied by 7 feet, since the entire length of the scaffold is 7 feet. This means the sum of the counterclockwise torques is equal to F2 multiplied by 7 feet. In step 6, we set the sum of the clockwise torque equal to the sum of the counterclockwise torque. If these two values are not equal, we don't have equilibrium, and the scaffold is going to rotate one direction or the other. We will substitute in our values in step 7. 711 pound-feet is equal to F2 multiplied by 7 feet. Dividing to solve for F2, we see that F2 is equal to 102 pounds. Finally, in step 8, we will substitute our value for F2 back into the force equation we found in step 2 to solve for F1. F1 plus F2 is equal to 250 pounds. Substituting 102 pounds for F2, we see F1 plus 102 pounds is equal to 250 pounds. Subtracting, we see that F1 is equal to 148 pounds and F2 is equal to 102 pounds. This concludes our center of gravity calculation.